That's like stickered on. This is I got this high school. Conversation started. I don't know. I have all this stuff. When I first got the cartridge, that's the part that shows originally was just like the game itself, like just a way to it. Put together, but the fact that it was created, and I started adding on a cartridge. The piece of footage is told. Of course. Since it's like a lot more. No, like how it already works. Go back. I think it's. It was a fun little project. So what do you start? I'm going to talk about it. See you guys. West Valley. No, I mean, this is awesome. So I think it's so. That was actually the talk that got me going. That was my first talk. Oh, was it? It was like I said that. But it doesn't. I saw the game. A lot of that. Yeah. You got at least one person. There we go. We're pretty far away. I did all known by the second place was like engineers, you know, building as well as all that. My Panelists like services. Nice. So right now, oh, okay, yeah. Well, you know, actually, it's the smart. It's really do like five, but that says so. Almost five. Like this is super I think it all balances out. Like there's a shortage of PDs, so there are a lot of there are a bunch of things. The only thing is like flying down. Charge my laptop. That sounds like it's that was good. Like that's why I don't know. And of course, the editors do things like automatically. Actually, yeah. Pushing you. Like you look forward to something. Oh, you mostly on like so yeah, but yeah, I don't ever use the I don't know. That's my favorite rides. I don't know what that would be their heaven. It's hard not to. Imagine if you have a fidelity account and you like kind of hack. Like here's the price. So good that I bet you are super youngest so many years. He's got to see the oh my gosh. I didn't know he's still there. That's good. That's something to see. Yes. Dragging like all the yes. Yes. Bought that piece of game at once. And then we filtered them all out. Yeah, like it's but nice. What's your role? So I'm dude, Linux like branch that they so much fun. It's actually a real team. I like that. For so long. I felt so bad for him. But it's like, yeah, now we have like, we have 3 engineers, a front end engineer, project manager. You guys on our team for the phone. She plants all our, she does a lot of She's got, my just crazy. That's my most things for yeah. That I got like plant, but like there's use plants, you know, like there's always things that pop up. Yeah, it's like I'm surprised when Aaron kind of going.
Another one.
I'm saying that there are
very good solution.
Yeah. Like the designers and we have like the designer, the manager, and like the engineering team. It's not that one. He went to school. School. And that web development. Front end. I was like, I don't think I hear more. Years, but it's okay. I made it. It's like part of. Oh, that's. Thing at ours. Only one boss. I like and then it's meet up and like, you want to write something? Most of my like I'm like, no, it's just, I just showed up. And so like that's where it's hard. It's like I don't know how to put that stuff.
Actually, rather than I think it would be more fun.
I'll learn it.
I think we've got everybody. So, all right. Good to be with you all. Go West. Interfacers and some others that are not so familiar. So welcome. Since your first time. Name is Paul McKay. Work at Weave. Blah 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 blah. But I'm here to facilitate this panel discussion of these experts in their field. Not out there, but Derek is the CEO of Nozzle, wonderful company. Casey, data expert in for blah blah. Yeah. At Weave. In Boston. Is that right? I've met you before, but now I know your name. Tell us a little bit about yourself.
Yeah, so I'm a software engineer down in St. George at Bayesian company. We work on print management and workflow automation. So what I work on specifically is business critical printing, hospitals, shipping plants, 100% uptime.
100% uptime. Okay. So we're going to find out if that's really true when it comes to databases. All right. So the forum or the kind of the outline of this process, we haven't had any panel discussions so far this morning, right? Nothing. Okay. So what we're going to do, a little introduction, which we've done. We have some pre-canned questions that I may use. And then we'll have some questions that you might have. See if you can stump them. Okay. So first of all, if I were to choose a database, well, let me first of all, why would anyone choose a database? I choose a database. Files are fine.
Yeah, if your Google Sheets gets too big, then you go to a database. Right?
Everyone's got that. Write that down. Google Sheets too big. Go to database. Okay, first one. Okay.
Yeah, Slack is a great database. Just put all your
All
information.
right, go on for the next one.
Also a secret manager.
Yeah, I won't go there.
Yeah, as much complexity as you can push out onto the database, it lets you solve concurrency problems, lets you deal with all kinds of hard issues that have been solved at scale by the biggest companies of the world with millions of person hours going into the database.
Okay, so there's going to be databases sometimes. You've established that. There's only like 2 databases to choose from. Wink, wink. How do you choose a database? What are some of the principles you say? Okay, I know I need a database, but which one do I choose from? Because we have our varieties. Every one of them says they're the best for every scenario or not. How do you choose? What are the principles that you use to choose a particular database?
You're right. There's only 2 choices: Postgres or MySQL. Any other choice is wrong, especially early on.
Oracle Rack is the only choice, I thought.
How much are they paying you to do that? Say that?
Nothing, but
Right? They're both. One that says MySQL is terrible is someone who had problems 20 years ago and none of their experience is relevant to today's MySQL. Postgres and MySQL are more similar today than different. Pick whichever one you have the most experience operating and you'll be happy.
okay, wonderful. Casey?
Yeah, I am a huge proponent of standardization. I think building tools around the tools you use is really important for any company. And so do what your company does. And then you can have the expertise of your other developers that work there help you get up to speed on that particular database. I mean, if we're just staying with relational databases, then yeah, there's two options. But
Oh, wait, okay. He just asked, well, excuse me, I'm gonna ask the question. What's rational about a relational database versus a NoSQL database versus the hybrid that seems to be kind of in between? Why would I choose one over the other? Oh.
Smooth. I'll give my thoughts on this. Relational is really good when your data is structured, you know what it's going to look like, and you're pretty confident in how it's going to be. But NoSQL really comes into play when you need things like text search. It's very free form. You're going to let any kind of data come in and out. So that's possible.
Okay, this is a question for the audience. No trick question here. How many are using solely a SQL database, a relational database?
Hands up. Only. Like this. I mean,
Okay. How many are using just a NoSQL database? And how many are using both? Okay, thank you. All right, I didn't quite understand then how to choose if they all use both.
This is my hot take. There's no reason to ever use a NoSQL database.
Sitting, there you go.
Postgres and MySQL are just as fast at key value lookups. You can store JSON blobs in them just the same as you can with a key value. There's no reason. If you do have like larger blobs, there's S3, there's GCS, there's object stores that you can put that out and store reference in your database. But unless there are very rare circumstances where an actual NoSQL database is worth the extra effort to stand up, to add it to your operational overhead, because you're still going to have a Postgres or MySQL. Most of the time you can do good enough full text search. There's obviously specific databases for things. You can do PG Vector, PlanetScale just announced vector databases in MySQL. You can do most graph relational stuff in a relational database. Unless you really, really, really have high scale and have actually flushed out all of the options available to you in your core database, don't look elsewhere. Don't cache elsewhere. Don't do anything elsewhere.
All right, let's get, oh, no, just a minute. Just a minute, because I know you want to hear the opposite. Why? Or are you gonna support Derek?
I will add on.
Oh, okay. There's a little
And I have had really good success with the SQL databases like Firestore. There's smaller reasons to use some of these NoSQL databases, but I do agree that it's the 80-20, right? So there's 80% of use cases, and most of those are satisfied by a Postgres or MySQL, and you should start there. Currently, we're running into issues with search in Postgres. There are extensions you can add to help with that. But we're getting to the point where we're into the use case where maybe we need something that's tailor-made for search. We're looking elsewhere for that right now. But we started in Postgres and we just lost search there already. So I'm kind of the opinion that you should start in relational, and then if you get to the point where you're kind of breaking at the seams, you can find a tailor-made solution for that thing.
Anything to add before we go to the audiences? Good. All right.
I was gonna ask, is overhead your main argument against it, or what else?
Overhead meaning,
Because you were saying, hey, don't use a NoSQL database because, you know, it's one more thing to set up, it's one more thing to maintain. Besides that, is there another reason you would say never use one?
That's basically it, just operational overhead. Then you have to sync between databases. A lot of them are by default eventual consistent, which now you've pushed a ton of complexity back out on your app devs. And again, except for some specific use cases for full text search, they don't generally offer enough advantages over your core database to make it worth the extra and for complexity.
okay, so now we had okay, Frank, I know you have an opinion on here.
Of course I have an opinion on this. Yeah, so I was just gonna say, it seems like, Derek, your first stance on why would you use a database, part of that was that it reduces the complexity of what you have to code. Oftentimes in NoSQL solutions, they don't reduce the complexity anywhere near the level that using a relational database will reduce the complexity for you. And so it makes sense that you would want to use a relational database basically whenever you can. But there are going to be cases where different scaling mechanisms, where different availability mechanisms might be significantly better on a NoSQL or a non-ACID with using eventual consistency. It works out fine if you go through and put in all of the extra work, which is a lot of extra overhead.
Okay. So, big data and relational databases. No problem.
I would say
Big data is not necessarily a relational database.
Wait. No, that's absolutely correct. They're not, but should you use a relational database for big data?
I'll give the same answer I gave earlier in that use it first, and then when you start breaking at the seams, then you can find a tailor.
Okay, Casey, breaking at the seams, trying to do it till, you know, okay, give me the edge cases of when I'm actually gonna make that choice. What are the things that I'm gonna say, just, Casey's right, I'm right at that point, I need to make a choice, it's gonna be NoSQL. What are the actual cases?
To me, the first one, so search is one, if that's really core to your application, maybe you go there. But again, having to sync data out, it's just so much extra overhead. And even if you might get some small operational efficiencies because the NoSQL, right tool for the right job, maybe it is perfect. But if you just put the same or even less work in, just adding more CPU, adding more resources to that database, Postgres will handle that just fine. OLAP, analytical databases that are columnar would be generally my first place where I would say, here's a completely different, it's not transactional. I have dashboarding needs and they're not real time in the same way that a transactional database is. That's probably the first time I would step out.
Some examples of those columnars that you'd think about?
ClickHouse, DuckDB, BigQuery. There's some cool new stuff happening with Apache Icebergs. What we're looking at moving stuff that you can store files on GCS or S3 and then expose it, and almost every data warehouse can read it natively. So it's pretty cool for separating your storage and putting it in a cheap spot versus locking yourself into one querying engine.
Casey?
Yeah, I'll just add that your use cases will tell you if you're breaking at the seams in terms of like you said, if you need real time, transactional workloads, and then it starts to get seconds where queries are thinking or multiple seconds or tens of seconds, then it's like, okay, well, my users are getting angry. And then you can go through like, oh, well, maybe I can optimize this or, change my queries to help make this better. And then if that, you've exhausted those efforts, then it's like, okay, maybe up to the billions or, even trillions of records. And then maybe I can move those into a columnar store.
Yeah, I think that's a great point. 99% of use cases, you're not gonna hit that. And so just going with Postgres or MySQL until then is gonna be your most efficient and effective, cost efficient choice to
So it sounds like
source this.
you hit a certain size, certain conditions where you may not need one versus the other, maybe one's better.
Let's, I don't know.
I think, I can't remember for sure. It might have been Figma, that recently published an article about, they thought they had hit that size, and Figma's not a small company, running just on Postgres. They thought they had made it there and started looking elsewhere and then decided, actually, let's just make some changes. And then they dropped their consumption 50% just by some of these smart optimizations. So again, most people and companies will not need to scale beyond just that initial.
Comment or question?
Yeah, I was gonna say, one of the big concerns with, NoSQL databases is, not being ACID compliant. But you have NoSQL databases, MongoDB after 4.0 being a prime example of an ACID compliant NoSQL database. So you can have all those perks of transactional databases with NoSQL. And to counter what's a good use case, in my opinion, for NoSQL is if you're a startup and you're not sure exactly what your product is yet, and you are rapidly changing how your data looks like having a relational database to start might not be the best option because you're going to be constantly doing migrations and such. I like the flexibility of NoSQL, and you have the perks of the ACID compliance with Mongo or another ACID compliant NoSQL.
So let me just follow up. So what you're advocating is fast moving, quick, flexible, kind of prototype, get it to a certain scale in NoSQL. Would you then think, okay, I've done that. Now go to relational?
I think it depends on the use case. Depending upon the nature of, your industry, if it's rapidly evolving, you're going to be adding a lot of extra fields and stuff like that, and you don't know what the object structure is. I'm not the biggest fan of storing JSON strings and stuff like that. So I like NoSQL for that reason, but
That smile means maybe there's
something's
another.
coming. Something's coming.
Derek,
I mean, Mongo is just a JSON string. It's not any different. And Postgres, MySQL, right? They're storing it as a binary. It's efficient. You can create indexes on it. So it's not that Mongo is necessarily bad. The Post 4.0 is a very important distinction on that.
so pre was bad.
Yeah,
Make sure we knew that one.
it was Snapchat for databases. But you can get most of those qualities with just a JSON column. And usually it's not like I'm slinging around brand new objects. Usually it's, okay, I have a core set of, here's my CRUD objects. They have an ID, but it's the properties on said object that are in flux or quickly evolving. And so it's still without having to do a full migration, though schema is a feature, not a bug, despite what NoSQL wants you to think.
Boston, you?
Yeah, I was just gonna also further his point that I think expertise is a big part of that. So he was talking use case of the product, you don't know what the schema is gonna be, but also if your expertise isn't in relational databases at all, it's probably easier to go NoSQL until you either are big enough that you're required to move or you're big enough to hire someone who has that expertise to make those right decisions.
Frank, you had your hand up before. Anything?
Mine is more related to a previous topic.
No, it can't go there. No.
Scaling.
Okay.
Talking about when should we scale?
Meaning, when we get to a point of scaling, when do we choose one to use?
A SQL database. I think this is helpful for people to know. What is the largest table that you have ran with in production that has performed well? Performing well is going to be qualified as less than 4 milliseconds for most queries. What's the largest that you've seen in a relational database?
20 terabytes.
Number of rows.
I don't know, trillions.
So scalable?
So it scales fine. That was on a single MySQL instance. I'm also a maintainer of Vitesse. That's a sharded MySQL option that lets you bypass most of those solutions. You've got GitHub, Slack, Square, lots of big companies running on it. So can scale MySQL or Postgres.
Yeah.
Vitesse makes it the sharding bit a lot easier than currently available Postgres options.
So, and then we had another comment here or a question, but before we go to that, so what I'm hearing is, for most of us, we always think I've got to go to that scalable solution because I'm going to hit it.
Yeah.
And most of us never will in our lifetime, right? So what you're saying is that they can scale up to a
It's not necessary.
99% of maybe our use cases, again, assuming that we're not a part of a huge Google-ish type, application. So interesting. Okay, you had a question or comment?
Good. I'll just speak loud. So two things. One, there's this false sense of I don't have to have a schema. You always have to have a schema. You always have to do a migration because your application is going to break as soon as you fetch the data that doesn't fit that new schema, or you're going to have the migration in your application logic where you're just adding all of that. So it's a false claim because you always have to have a schema. It's where do you put the complexity? Do you put it in the database or do you put it in the application? And then there we go.
Recommendation? In the schema or in the application?
I'm on the schema side because then you have the tooling to handle it for you, right? There's no tooling built to handle custom application logic. There is tooling built to handle schema migration. Oh, and that was my other point was that there's also this false sense that you have to create a column for every single value, which is not true. You only need to create a column for values that you are going to index or search. So everything else can go into a JSON blob in a relational database. And that's probably what you should do while you're starting out so that you don't end up in a case where you're like, oh, all 53 of these columns for properties I may or may not use, I've created. Now I have to do a migration. Now my migration sucks and you're getting those pain points of thinking, oh, I wish I used NoSQL. No, what you wish you did is that you didn't index every single column when you actually weren't going to use it.
You have a very,
Yeah.
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 all right. We won't vote on the but I think there's a lot of good advice there.
Quick note on that. You can, in both Postgres and MySQL, you can add indexes even on nested, repeated JSON. So
Yeah.
there's not even a requirement to have a separate column for an index.
All right, one more. Go ahead.
Yeah, I was just going to comment that the sentiment is optimizing for change, which I think you should do regardless. NoSQL or we use Goose at Weave and for migrations in Go, and we have migration folders that are like you open it and it goes down really far, but that's fine. That's what the tooling is meant to help you perform.
All right, let's move on to another one. We kind of touched it a little bit. Do you have a question?
Oh, no, it's not related to relations, ironically. But another question. I'm curious of the most common worst practices you see with database integration or implementation.
No, wait. I just want you to look at the slide. Okay. This is not the worst, best.
But what are
Unless somebody's going to change that.
listen? I'm just trying to give my team a hard time, put some bad code out there, get some work on.
So, what are some of the worst best cases for practices?
You touched on it earlier. People often think, oh, this database is slow, and they just don't have an index. So 95% of your problems are going to be fixed by either adding an index or people think something's using, especially if it's like a multiple column index, and they think they're using an index, but they don't have like that first column. And so that index isn't used at all. So almost all of your problems for database performance are going to be solved with indexes.
So start out by indexing everything.
Exactly. You want
Is that the worst one?
you want 1000x the size of your table in
Okay,
indexes.
We will audit we'll cut out this in the video. It's not a best practice. But let's just follow that. When do you decide that you need an index, and how many of those indexes?
with every optimization, doesn't matter if it's database or elsewhere, when you notice it in your monitoring.
Okay.
If you don't, then it's not a problem. Don't spend your time
So
optimizing.
data drives, not assumptions. Good practice. Did you have any more on that follow-up or anything like that? Okay. All right, we did kind of talk about it from application versus the schema, blah, blah, blah. But let's just talk about the design of
If
API.
I- one quick one.
Oh, okay.
The other one, holding transactions open too long. I see an anti-pattern. People come in and they're like, oh, I'm going to do this magical transaction in my Go context. And I'm going to open it when the request comes in, and I'm going to commit it when it comes out. That is the worst thing you could possibly do to a database.
So how long?
Playground.
Want nothing but your transactional code running where possible. Make any external API calls, do whatever you can outside of your transactional context. Otherwise, you'll get a ton of deadlocking and cause performance issues that, again, are your bad practices, not database performance
Okay,
related.
just a quick follow-up.
Feature.
Would you suggest on the whole, maybe not every case, that a transaction should be within the boundaries of a function?
I don't think so. One thing that
And I think we're gonna use the.
I'll stop out with a no.
I was gonna add one more thing that I notice as a bad practice is in general, people rely, I feel like, too much on the magic, because there is a lot of really great things that Postgres or MySQL do for you, and there's a lot of tooling around them that do a lot of things for you. And I feel like at times teams or developers, especially early on in their career, just expect it to work and they don't need to know about it. And obviously you could go really deep all the way down to the internals of the database to get to understand a lot of things. You don't need to go that far. But I feel like a lot of times developers will just say, oh, if I don't understand it, I'll send it to a data team that understands it, or send it to someone. I would just suggest,
But that's you, Casey, at Weave.
I know.
Yeah. So it's jumping on
If
you.
all the developers knew, exactly how to add an index or when to add an index, or like, and all of the query optimizations they can do, then, maybe I wouldn't be needed, and that's fine, because they would all know how to do it, which is great. But I would just suggest, if you're running into issues, instead of like, oh, jump ship, go to a new technology, or throw it over the wall for someone else, I would just suggest to dig in and say, hey, if I don't know when to create an index, maybe I should learn that.
Yep.
And just go a little bit deeper. And that's one of the biggest problems I've seen.
Good advice. Boston, do you have some?
Yeah,
Adam?
I'll just follow with my hot take. Might be hotter than Derek's. We'll see. I don't like ORMs. Don't use an ORM.
I was gonna go there next.
So, and this kind of furthers what Casey was saying, like, instead of just tossing it over to your ORM, understand what it's doing, and maybe you even do it yourself so you can get that optimization.
Question.
Yes.
You kind of touched on the thing that I've been wondering about. My team is tired of me saying, but what about the data model? Because I feel like there isn't enough expertise on a lot of development teams thinking about data and the databases, data modeling and databases, right? So how do we all get smarter at that? I feel like, a lot of us work on our Go skills, right? But we don't throw the same amount of work at data stuff, data thinking.
Nobody uses data, but that's okay.
But we all have to use it, right? And part of what's so frustrating about relational databases sometimes is you feel like you're stuck with somebody's bad decision for years, right? So frustrating. Yeah, what do we do?
So the comment is, we train on other technologies. Data is really, you look at what we do. I don't know about, I'm gonna make an assumption, but I don't think there's anyone here that doesn't use data. Right? But we don't focus or fine tune or get better at data.
Don't have a person on the team who's specifically thinking, how are we going to model all of the entities that we are coming up with?
I think that's the most important part for any database, right? It doesn't matter what the technology is. Data modeling is the most important. It'll, like you said, it causes problems so the more time you can spend up front deciding how am I going to store this, how I'm going to query it is going to pay off for team members that might be complaining. I think I would say just for their own career, there's nothing that has stood the test of time like SQL. It's, we're going to come up on a century here of it, pretty quickly. And it doesn't matter what language they use. It doesn't matter what they're doing. Nothing has shown any sign that it's going to make SQL irrelevant. Even, new SQL or NoSQL databases, they're trying to build compatibility layers because it just works. It's not perfect. It has its warts. You can't have trailing commas most of the time, right? It's annoying. It's hard to compose, but it's what's there. And so investing time and getting better at it is just going to pay dividends through the rest of your career.
All right.
I wanted to make one point out to that as well. It's just as bad as having no engineers who know databases as having only one or two and having that silo. And so I think that's also super important is if you're on a team where only one of your engineers is your data expert, when did they get to go on vacation? Like, when do you get to plan a sick day and everything? So that's, I think, another key aspect is skilling up all our engineers to know at least a little bit, like indexing well, and then just basics of this is good data, this is bad data, and how do we integrate that?
Kind of interesting. We're talking about these technical things, but Zach's bringing up probably a really big one. Is that there's some organizational acumen and just how you do things to make sure that things
Work. Yeah.
and continue that continuity. All right, we have to finish up. Oh, go ahead.
I'll just say last bad practice that's relevant to that. I hate the repo pattern. Or when people try to abstract their databases away, like, well, what if I'm going to switch from MySQL to Mongo or something else? That's not going to happen. And
Oh,
when you,
wait. Let's ask, because that was gonna be my question. Everyone loves to have these abstractions because you know where you're gonna switch next week to another database. How many have had that that ever actually saved the day having those abstractions? 1, 2, Dave, come on.
Pretty good.
I mean, I used it, but we ended up switching back to the original.
This person right here.
it means you're doing the lowest common denominator. You don't get to use anything special about the database you are using. You're going to have performance issues because, oh, it's just my magical little repo and it does a thing. And I feel like the primary reason it existed in the past was it made testing easier. But today it's easy enough to spin up a Docker container with an actual database. Just do that. You don't need a repo pattern. It's fine to pass a transaction and not have it be this magical repo. So
All right.
no abstraction.
Did
Lean
we
into the
learn-
database.
did we learn some stuff? Everybody?
What?
AJ?
I just want to point out, if you want a detailed list of his arguments to share with someone else, a coworker, a manager, there in the Node community, there was an article came out called "Stop Using Connects.js." It was about a thing called Slonik. So if you remember Connects.js, and Slonik is like Russian for elephant, Postgres. But it goes. Have you read that article? It's line by line. It's like, you're not actually going to switch the database. This is not actually going to happen. You still have to know the SQL. You're still going to have to decode the errors. You still need type safety. And it just goes line by line and just breaks down all the myths.
If you're in Forge, could you put that link for the rest of us that?
I'll
have
put it in Discord, Forge.
That'd be wonderful.
Thank you.
Perfect. All right, we have to finish up. Let's give a round of applause to Eric.